Hello all, and thank you for listening to Mr. Laxton's video on these Algebra II Section 3.2 notes. So today we're looking at how do I solve systems of equations by substitution and elimination. We looked in Section 3.1, we looked in how to solve these guys graphically. So we took the lines, we got them into y equals mx plus b, and we actually physically found, hey, where do they actually intersect? All right. Now today we're going to look at it and do a little bit more behind the scenes. We're going to do some algebra. All right, so we're going to solve these by substitution and elimination to find out, hey, where's my x in which they intersect and where's my y? So we're just finding that point, but we're doing it algebraically instead of more that concrete graphically. All right, these algebraically ways I think actually come up to be a little bit quicker once you get good at them, but we'll talk through them here. All right, so the first one is substitution method. All right, I'm going to kind of walk through these step by step as I walk through this example here. So it says step number one, it says solve one of the equations for one of its variables. All right, choose the one that looks easiest to solve. So if I look here in the example that I'm given, I already know that y equals negative x minus 2. So I have one of the variables already solved for, I have it solved for y. All right, most of the time when you go through these guys and you want to do substitution, you pick one that's already solved for y or x. All right. If it's not solved for y or x, you're going to use probably this linear combination method or elimination. All right. That's just going to be the easier way to do it. We're going to talk about that in a little bit. All right, next, substitute that expression into the second equation and solve for the other variable. So that's kind of a lot of words there to say that, hey, I know that y equals negative x minus 2, so I like to circle that negative x minus 2. And look at this. I can just plug this guy in for my y over here because I know that negative x minus 2 is equal to y. All right, so now I'm just going to rewrite this equation. I have 2x minus 3, and instead of writing y, I'm going to write negative x minus 2 equals negative 9. All right, so I substituted this value of y in for my y over here. And if you notice here, now I only have one variable. I only have x. I don't have any y's into this equation right here. All right, so now the second part of number 2, we're going to solve for that variable. So now, hey, we have 2x. I can distribute this negative 3. I like to have a plus here, plus a negative 3. So this is going to be negative 3 times a negative x is going to be 3x. And then negative 3 times negative 2 is going to be positive 6 is equal to negative 9. All right, so now I got to go through here and solve this guy so I can combine like terms. So I got 2x and 3x makes 5x. I can subtract this 6 over in the same step, so I have 5x is equal to negative 15. Divide by 5, I get x is equal to negative 3. Okay, so I solve for one of the variables. So that's a majority of my work right here is I say, hey, I got my x, now I have to solve for that y value. So now it says use the reverse equation from step number 1 and plug the value and solve for the first variable. So all we really have to do is just plug this x equals negative 3. We got to plug that into this equation back up here. All right, you can plug it into either equation, but I think this one's easiest because it is y equals, and then now it's negative, and instead of writing x, I'm going to write negative 3, and then minus 2. All right, so I substitute, and you kind of substitute this equation here, and then you go through and substitute this equation here. So there's kind of two different substitution steps. So now I get y equals the negative of negative 3 is positive 3 minus 2. Positive 3 minus 2 is y equals 1. So my equation, or my solution to my system of equations here is negative 3 for my x, and then 1 for my y. We always kind of like to write it in that coordinate point form. Here's my x, here's my y. All right, so negative 3 comma 1 is where these two lines intersect. So we found out that point of intersection. We did that without even graphing them. All right, if we were to graph these guys, they would intersect at negative 3, 1. All right, awesome. Again, you can always go through and check your answer algebraically. So you can plug this negative 3, 1 into both of these equations, this guy right here and this guy, and make sure that they work out for you. All right, awesome. So now the next one is linear combination method. All right, it says linear combination. I like to call it the elimination method. Elimination. All right, doesn't matter. Either way works. Elimination, linear combination are the same deal. Okay, this one's actually pretty cool, pretty nice once you get the hold of it here. All right, so it says arrange the equations with the like terms in columns. So if you notice here, I have my x's in a column, I have my y's in a column, and then I have my numbers in a column. All right, they're both in standard form. So that's why it wouldn't be easy to graph these, because you'd have to move them both into y equals mx plus b, then you'd have to graph each of those lines and find out where they intersect. So this one's going to be a little bit easier to do this elimination method. So I'm going to erase both of these guys here. All right, so it makes a little bit more sense for us. All right. Here we go. It says now multiply 1. This is kind of the tricky part of elimination. Multiply 1 or both of the equations by a number to obtain opposites for one of its variables. So if I look here, I have 6x and I have 4x. All right. Now here I have 4y and I have negative 2y. I want to make these guys the opposites. So again, opposites, like the opposite of 8 is negative 8. So if I notice here, when I add these guys straight down, it's going to make 0. It's going to eliminate. And that's going to be kind of the deal here that we're kind of looking for. All right. So if I look at 6 and 4, I look at, hey, I can't multiply 4 by anything to get 6. I can't multiply 6 by anything to get 4. Not any nice numbers, at least. All right. So that one, I say, okay, we might come back to that one. We might have to. But let's look at the second one. Let's look at my y's. So I have negative 2y and 4y. I look at this one and say, hey, I can multiply this bottom equation by 2, because my top one is 4y and I want to make it negative 4y, so they end up canceling out. So if I want to make this one negative 4y, I want to multiply negative 2 times 2 to give me negative 4. All right, that's kind of the tricky part of this elimination. You want to try to make opposites. All right, awesome. So here we go. The top equation, I'm not going to move. I'm not going to change it all. I'm just going to move it over here. So I got 6x plus 4y is equal to 16. The bottom equation, everything needs to be multiplied by that 2. So 4 times 2 is 8x plus negative 4y is equal to 6 times 2 is 12. All right. Awesome. So now I go through here. Let's add these guys straight down. So now I add them straight down. That's number 3. It says add. I don't really like to subtract. I just kind of like to get opposites and then add. So here we go. If I notice when I add these guys straight down, 6x and 8x is 14x. But now I notice that, hey, 4y and negative 4y, those guys go away. That makes 0. I eliminated the y. And then now this is equal to 16 and 12 makes 28. All right, so now this is a pretty simple equation. Now I just divide by 14, so now I get x is equal to 2. All right, and then just like we did up top, now I found my x is 2, I can plug it into either one of the equations to find out what my y is. It does not matter which one you plug this in for, this x or this x. It does not matter. I'm going to go 6 times 2 plus 4y is equal to 16. So this is going to be 12 plus 4y is equal to 16. I'm going to minus the 12, so I get 4y is equal to 4. And then I get y equals 1. All right. So now I see, hey, my answer to this guy is 2, 1. I eliminated a variable, and then I was able to solve for what that x is, and then I plugged it back in to solve for my y. Okay, so I know that 2, 1 is where these two lines, this guy right here and this guy right here, it's where they intersect. All right, awesome. So now the couple examples down here is that sometimes you end up with this no solution, infinite solutions. All right, and it's the same deal here. It's just now we want to talk about, hey, what does infinite solutions and no solutions look like when we're doing it algebraically rather than just graphically? All right, perfect. The first one, if I have these two guys, I look at this one and say, hey, I want to try to eliminate elimination here because I don't have a variable that's solved for. So now I have to ask myself, hey, how can I make opposites? And I look at my x's right away. I kind of look at my y's because these are smaller numbers. That's a 1y. So I looked at this guy and I want to multiply this guy by negative 2 because I have 1y here and I want to make it into the opposite of that, which is the opposite of positive 2 is negative 2. So now as I go through and I multiply these guys straight in here, I'm just going to rewrite this one right underneath it so I save myself some room here. I have 4x, negative 2 times negative 2 is 4x, positive 4x, plus a negative 2y is equal to negative 2 times 3 is negative 6. So now as you look here, as I add straight down, what do you notice? My x's cancel out. I didn't even try to do that. My x's cancel out, my y's cancel out, so I have 0 left on this side of the equal sign is equal to 6 plus negative 6. Oh, look at that. That turns into 0 as well. Okay, so you have to ask yourself, 0 equals 0. Does 0 equal 0? Yes. All right, yes, 0 does equal 0, so this is infinite solutions. All right, this is infinite solutions. All right, now if I look at this next one here, I want to try to create opposites here. I look at this 1x again. I want to try to make that into positive 2 because this is a negative 2 here. So I'm going to multiply this guy by positive 2, this guy into all these guys. So now I have 2x plus a negative 4y is equal to 2 times 5 is 10. All right, add these guys straight down. You notice here that, hey, my x's cancel out. That's what we were trying to do. That's good. Now we also notice, hey, my y's cancel out. All right, so now I get 0 is equal to 0 plus 10 is 10. Does 0 equal 10? No, 0 does not equal 10. So this one is no solutions. All right, so a couple different things there. Most of the time you're going to end up with one solution like this, but sometimes you end up with that infinite and no solutions. All right, so the goal there for elimination, you want to try to get opposites in one of those columns, either the x column or the y column, and go through there. All right, so thanks again for listening to this video on these Algebra 2 Section 3.2 notes. Make sure you hit that subscribe and have a good rest of your day.